Thank you for this introduction. My name is Marcin Moskala, and I am a speaker, teacher, trainer, and author. And today I have a very ambitious plan because I would like to show you the most important concepts of coroutines. And this is not a small set of knowledge, so we have a lot to discuss today. And especially I will tell you why do we need coroutines. Then this will be the hardest part. How does it work? I will try to explain how on a deeper level coroutines really work. And then we will use the rest of our time to explain some basics of Kotlin Coroutines library. So let's start from why. And I believe there are two very distinct whys for two different kind of peoples, for backend and for front-end developers, since these are two very different worlds. Okay, we are in a mobile conference, so most of our are front-end developers, but I believe some of us do a backend, and this is also an important word, so I will also mention some reasons. So let's start and focus on front-end development problems. So a typical front-end development problem looks like that. So we have some function in which we obtain some data from the server, we do some simple processing, in this case just sorting, and we display on the view. Of course, this is not how programming works. It cannot work this way because we would block a main thread. So in here we would have an error that it cannot run network operation on a main thread. To fix that, we need to run it on a separate thread. But again, right now we cannot show this data on a separate thread. We need to switch back to a main thread, and this is a working solution which looks very bad. It's far from what we had on the beginning. And there are a few ways to deal with this problem. And the very simple one is to use callbacks. Callbacks is a function that is called once operation is done, so it all runs on the UI thread. We just don't really wait for these newses. We get back to the rest of the function once newses are there. And callback is a good solution for this simple problem, but it doesn't work for more difficult problems. Say that we need to get more data from our API. And you can see very clear problems with callbacks. First of all, user from API and config from API can run simultaneously. And you cannot do it, I mean, it's very hard to do it using callbacks. So the design of this solution blocks our parallel processing. Second of all, we have this. This nesting that grows with every call is very problematic to maintain a code, and it even has its own name, that is a callback hell. This name comes from the environments where callback hell is very problematic, like Node.js. And I think that every Node.js developer has made something close to that. So callbacks are problematic. What about RxJava? This is a very popular solution in Android. But for this very simple case, notice how much do we need like boilerplate code just to handle this simple request. And also we have many nesting, many different structures. It's just complex. When we come to the second problem, it's not really getting easier. So having, we first of all, there is a boilerplate, mixed with a logic. So in some place we get from config from API, and we need to flat map it because this other call request depends on the first one. We simultaneously do the second one, so it works better, but there is a huge amount of code, and in general it's very problematic. So RxJava is some kind of a solution, but it's not such a great solution. Oh. I think we have a problem in here. So I will show you in IDE. So this is what I wanted to show, how it might work in the Kotlin Coroutines. Sorry, it's not on the slides. So in Kotlin Coroutines, you can do it all in one level, have it on one indent, and get this news from API, wait for that, but without blocking a main thread, and then do the rest of the processing. So conceptually, it goes on a main thread all the time, but then it suspends this main thread. We don't block this thread, so it can be used by some other threads. And once we have our request back, we continue on this thread and we run further. Let's see the other example. So this is not this is a callback solution implemented in Coroutines. I will show a better solution in a minute. So, but remember, this one does not work simultaneously. So we first we first wait for user data, then we wait for config from API, then we wait for news from API. So it's the same solution as in callback. When we don't wait a main thread. We get back to this function once we have this data. But what is important is that we don't have callback hell. Everything is flat and on the same level, so it is way easier to process on that. How it might be implemented? Well, we just need to use async await. And what is very important is that async await is not a special keyword. It's just a part of Coroutines library that can be implemented by any of you as long as you have these suspending functions that can be suspended in any point. So this is not a special structure. It's a part of library and something that might be implemented by anyone. So right now these calls are run simultaneously. So we get a request for get user data and get config. To start a request for news, we need to await for config, and to show news, we need to await for user data and for news data. Is it clear? Cool. We can do many more things with coroutines. We can use loops. So here we get some news from a network, and then we load these pages one after another. So it runs on UI thread, but it doesn't block it. So it's like it takes just a little bit of processing to display this new news. Then when it waits, it releases this main thread. After when we have request back from the server, we take main thread for a few operations. We display it on the screen, and we suspend it again. So this is a way to make the logic when user comes into the application and new newses are loading one after another. And this is very simple to do in using Kotlin Coroutines. Okay, these are front-end problems. There is one very important back-end problem that is connected to coroutines. So this is a classic problem, coroutine problem classic problem in backend. So we need to get some data from database. We do some processing and we respond this data. And of course, this is how it not works because we cannot database operation generally takes some time. We cannot wait for that on the same thread as for everything else. So what happens is that it's packed on some kind of thread. And it works with only one problem. Thread takes around 2 megabytes of data. And now think that it takes half a second to get data from database. And you have 100,000 of calls every second. So your memory is gone very quickly. And just to show you this, I can show you. Sorry. Okay, so this is the same problem presented in coroutines. So in here, launch is like a separate thread, and we simulate 100,000 requests, And on every request, we wait for a database, and then we do something. And when we run it, we wait a second, and immediately we have a whole result. If we try to do the same using threads, we will have a problem. Because we will have some dots, but we will very quickly have unable to create new native thread because we are out of memory. And yeah, this is a very important problem and one of the key reasons why coroutines are so popular for backend development right now. And this is a very good solution. So how it is possible? Let's go a little bit deeper how coroutines work. And to explain it, it's good to see coroutine sequence builders. So sequence builders is a known concept from many words. In Kotlin, they are implemented using coroutines. So we have a builder that yields number one after another. So it prints some statement, yields number, prints some statement, yields number. And when we iterate over that, we first obtain the next number. So you can see that when we iterate over that, we first have first number is 1. Then we get the number, so we can run our inside part of the loop. Next number is num. And then we get a next part, etc., etc. So we just make part of the function, we stop there, and we get back to this function a bit later. This is even more visible in the slightly modified example. When we don't iterate over this sequence, we just take first element, then we take second element, and we just stopped. And notice that at this point, I might do many other operations, and after some time, get back to this and get next, and start from the second point, print 2, 2, 2, 2, 3, and then get next element. So it's like we can go into function in the one particular point, get some operation until next point, stop there, and hold this state somewhere. It can be even serialized. To be honest, I could serialize it, serialize this function at this point somewhere, and it's not that build sequence is serialized. Now it's a coroutine builder is serialized. I could save it, and I could copy it, and I could start in many different instances from the same place when I end it. So this is the key idea is that function is stopped at some point and can run from this point until the other point. And I know what you think right now. Well, I work with functions all my life, and I know that how function works. This is not how function works. One does not simply stop function in the middle to continue it later. And actually, it is possible in coroutines, and to understand how it works, I will show you a very simple example with only one suspension point in the middle. So this is a suspending function, so it can be suspended, and it is suspended during delay. Delay is not the same as thread sleep because thread sleep blocks thread. Delay suspends coroutine and get back to this coroutine later. And how does it work? So this is not the current implementation. This is an old implementation. But I wanted to show you this implementation because it's way easier and it clearly shows how coroutines work. So when you start delay, it suspends coroutine, but before it suspends it, it gives you a continuation, and it lets you set scheduler. So you set scheduler to resume this coroutine after a set amount of time, and you resume it using this continuation that was passed. So this continuation is state of the function yet to be executed. Continuation itself is just an interface with just a resume with, or traditionally resume and resume with exception. Resume with is a result that is either a success and some data, or an exception and this exception. And there is some context. We are going to talk about context later, but it might be empty. This is just a holder for some additional data to parameterize this coroutine. So the continuation holds a data about the state, and this is a generic interface to define it. This function is compiled into a bit different function that looks a bit like that. It's not the direct implementation, but it's a bit simplified implementation. So every suspending function accepts continuation as an argument. So we can see that there was no argument. Right now there is a continuation as an argument. And the first step, this continuation is wraps. If this is not already a continuation from this suspending function, it is wrapped into a special class that is generated just for this function. So every suspending function has its own class generated, continuation class generated to represent this suspending function. And this special class have few properties, and one of them is the label. Label is an integer that says where we should continue. And this label at the beginning is equal to 0. It means that we start from the beginning. And so when we go into state machine, so when we go into the first if, label is equal to 0, so we can go into the body and we can print A. So we are at the beginning of our function. Then we get into suspension point, and before suspension point, we need to set label to a new state. It will be important once we go back to this function. So we set label to next state, and we call our function that might be suspending. And if this function is not suspending, it will return unit, so nothing important, and we will continue. We are in another state. We are printing B, and we finish our function. It's normal. But if this function would suspend our execution, it will return coroutine suspended, and in such a case, we would also return coroutine suspended. And notice that the return type of getConfig is any, because it's the closest supertype of coroutine suspended and string. So to visualize it in a diagram, it works like that. So first we have some continuation passed into our getConfig. Then getConfig wraps it into its own continuation class and pass it into delay function. Delay function schedules continuation after set amount of time and suspends coroutine. So this is all happened, and all that happened. It suspended coroutine, so it returns coroutine suspended. We catch it, and we returns coroutine suspended, and this way it's propagated until the top, until the coroutine builder, and it's done. This is where it ended. For 1 second. After 1 second, scheduler resumes coroutine. And this resume is a part of a special class generated for this suspending function. So this is in newer API resume with, in our older API resume. And this special class is generated from this suspending function, and it calls the resume. In the case of success, it calls its suspending function with a reference to itself. So getConfig is called with this continuation. And notice that we already set a label of this continuation to the next state. So we will continue and getConfig from the next state. So if you go back in here, we already set continuation label to 1. And so when we will start this continuation, this getConfig, we will jump directly to this state, so we will just print B and return some config. I know it might be confusing, but you have it all recorded and it will be on YouTube, so we can get back to that. There is one more concept I would like to add in here, and to explain it I need a bit more complex example with 2 suspending points and some data hold. So this function generates something that looks like that. And the key point, the key element of this is the config and news. Notice that the function tries to get it from continuation. So this is a special continuation generated for this class, so it has these fields. Of course, these fields are nulls in the beginning. So I mean, they are not filled at the beginning, but it's trying to get them. and this is like our state. So if we continue from our continuation from some state that already had some local properties that we need to restore, it will be taken from this continuation. So this is why continuation holds all the state. It holds the point where we should start by label, and it holds all the properties that might be used on the next parts by special properties. And this is exactly why continuation needs to be generated for each suspending function. So yeah, let's analyze it very quickly. So at the beginning, we start with label 0. We get into first if. We set label to 1. We try to get configuration. It depends. If this is suspending, we suspend it. After some time, we restore from coroutine and jump into next state. If it is not suspending, we just filled our configuration. Config is not coroutine suspended, so we can get into next state. And the same happens in the next if. We set new label, we try to fill data. If this data is returned, then we can go into next label. If they are not returned, then we suspend everything. We forget about something for some time. After this time, everything is filled from the continuation. So yeah, and at the end we can just do this processing and finish our function. So yeah, as you can see, it's pretty simple. Everything is on YouTube, so you can get back to that. Though I think I passed the key idea, how does it work? And the important thing to understand is that what I explained right now is a built-in support for coroutines. So how it is possible that function can run and can be suspended at some point. This is a part of built-in support, and this is something totally different than what we generally think about coroutines, that are coroutines libraries. So coroutine support is built in, while coroutines library is a separate library that is distributed separately, and you need to add it to your project. Generally, coroutine support gives you just a few modifiers, and it's very minimalistic, while coroutines library has many functions and classes that are very useful. And built-in support gives you a possibility to reproduce as far as I know, every existing concurrence model that you want. They made very many experiments with replacing different concurrence models for different languages, and all we need to do that is the coroutine built-in support. But on the other hand, coroutines library give you its own way of doing concurrent programming using these constructs. So I would like to give you the basics of Kotlin Coroutines library, since this is very useful, and I hope that you will use it in your projects. So the first concept is a coroutine builders. So as you see, every suspending function needs to be executed in suspending points because it needs to get this continuation somewhere. But we need to start it somewhere. And the functions used to start it are called coroutine builders. And you've already seen launch. Launch is the kind of an equivalent of thread in the classic way of going with that. So it just starts some execution. And it doesn't care about result, though it has some life cycle, and Kotlin Coroutines library, every coroutine has its own life cycle, so it's a job and it can be joined. Notice that without this run blocking, we would see no result, because our program would finish before this coroutine finished, so it wouldn't wait for it to finish. The classic way to deal with that is run blocking. So if you have a main function, and if you experiment with main function, normally it will start from run blocking. Run blocking is kind of a classic way of execution. So you are waiting for every suspending function. So it's very useful in main because it does not let program to end before your jobs are ended, but it's not so helpful if you do Android or web or backend development, though it's very popular for testing and experimenting with Kotlin Coroutines. And yeah, this is a very simple example. We just measure time, we wait 2 seconds, we do something, wait 1 second, and everything takes 3 seconds because we wait every time. We suspend our main thread every time we wait for coroutine to end. The third most important one is async. You've already seen it. So it starts job immediately, but it cares about result, and we can always await for this result. And as you have already seen, most language has built-in support for async await, JavaScript, C#. In Kotlin, this is just a top-level higher-order function. There is no special support. So support is way more minimalistic, and it gives you a possibility to implement it yourself. A very important concept is a coroutine context. So the coroutine context is just a set of properties that might have some meaning, but they also might have not. So in the built-in support, they don't really have meaning. But there are few coroutine contexts, like there are few kinds of elements in coroutine context that have some meaning for Kotlin Coroutines library. And the 4 most important of them are, first, the name. It's just for debugging purposes. So if you need to do some debugging, coroutine name is a context that will give you how this current coroutine is named. Second is a job. Job is a life cycle of coroutine, and it is especially useful in Android to cancel our coroutines. We will see it in a second. It can be also used to await for some coroutine or coroutines. Yeah. There is also coroutine exception handler, another very useful thing. You can pass it as a context, and it will give you the way of exception handling for all the coroutines you started with this context. And the last and the most important one is coroutine interceptor. So this is, just like a god of all coroutine context. This can be used to do nearly everything, but it's because it intercepts the continuation. So every time we continue, it intercepts that. But it's mainly used to define dispatchers. So dispatchers in Kotlin Coroutine are special kind of coroutine context that are used to set a thread on which we execute our function. So the most popular dispatcher that is used by default when no other dispatcher is set is a dispatcher's default. This is something that acts like a thread, but of course it runs on a shared pool of threads, and it's way optimized. In general, if we want to do something in a separate thread, we just use default dispatcher. The other one is a main. So main does not, it has a meaning for different platforms and does not have any meaning for some platforms. So in Android, this is UI thread, the same in iOS, but on backend, there is nothing there, so you cannot really use it. But it's a common way to say that we want to run something on a main thread. It's a main dispatcher you will use on Android. There is I/O. It's like a one thread that is used to do I/O operations. So they don't happen in the same time. Or notice, if it's a very common pattern, by the way, if you have a dispatcher that dispatches everything on a single thread, you force that all operations inside this coroutine will go sequentially. So one will wait for another to wait. So it's a common way, for instance, if you need to run all database or some shared state operations in the same. You cannot run them simultaneously. You can just set the same dispatcher for all of them. The same dispatcher that directs the same thread, and they will not run in the same time because they will wait for each other. And the last one is unconfined. It just does not change the current thread. So it uses the previous thread. It's like a cheapest dispatcher. When you've seen the launch function before, it was kind of a lie, because right now launch function is not used anymore as standalone. It's deprecated, and instead of pure launch function, we should use a launch function that is an extension function to coroutine scope. What is this coroutine scope? So coroutine scope is an interface with just a single property that is coroutine context. And the general logic is that all coroutine builders, they like first take the default coroutine context, then they update it with coroutine scope context, and then they update it with set coroutine context. So it's like this, it's like the hierarchy. And the reason why this is deprecated and why it's enforced to use it as an extension function is the idea of structured concurrence. So imagine that we have a coroutine inside a coroutine. It's a very common case when we have, for instance, branch blocking and some launch instead. So in a classic way, we would have to do it this way. But in a structured concurrence, we would, first of all, we would get rid of this global scope. So in this case, this is still an extension function because this is lambda expression with receiver. And on a coroutine scope. So right now, launch runs on a coroutine scope. This coroutine scope is a coroutine scope taken from run blocking. And thanks to that, we don't need this delay anymore because the coroutine scope that is passed by run blocking has a context that enforces a wait for the last job before main thread, before this run blocking is finished. So this is a very, the concept in general of structured concurrency when we create a coroutine inside a coroutine and we add new elements of context, it's a very, very big and powerful context for a separate presentation. But in general, it's an important idea I would like to pass you. For you as an Android developers mainly, this is the most important slide because it shows how you can use coroutines and coroutine contexts in Android. Do we see everything? Yeah, we see everything. So yeah, normally most of that would be extracted to some base presenter or some base activity. I just want it all in one slide. So we set coroutine context and we add some elements to that. We add dispatcher's main to run on a main thread. It should be clear for you right now. We also add job. Why do we add job? So right now all our coroutines have context, have life cycle, and we can await for them. We can do some things, including we can cancel them all on destroy. So if our activity is destroyed, we can just cancel our coroutines. We don't wait for our responses for API anymore. So this is what we already did in RxJava, though on RxJava it was way harder because we had to collect all these observables or disposables, and right now you can just use coroutine context to make like one job for all coroutines and to cancel them all. This is actually why it was designed for. You can also add a single exception handler for all these coroutines that are built. And so here we set some exception handler that show error and print stack trace. Notice that these launches, they are extension functions on coroutine scope. So our presenter implements coroutine scope. So these launch functions, both are an extension functions, so they are not deprecated, and they take this coroutine context from our scope. So in this way, in practice, this and all this coroutine context setting will be probably in some base presenter. So on the end, on our normal presenter, we'll only have on start with already context that we want to run our coroutines on. And if we want to change something, let's say run something on a separate thread, we just add here coroutine context equals to dispatchers.default, and we change the thread to main. Any questions to that? Cool. Coroutines are highly supported by different libraries, including most important library for Android developers, that is Retrofit. Support can be found in few actually adapters, including one made by Jay Quarton. And all we need to use it is to add call adapter factory, and then we can just use deferred type on my service. So deferred type is it's just a type with await and join. It's exactly what is returned from async function. So it means that if we call getUser, our request is already sent, but we will await for that. I mean, we can await for that right now or later, and this await will return us a concrete value. So this is a very, very nice support, and it works very well. And yeah, it's made by Kotlin. So it's a very, very good thing, and we have similar support for many other things. Also, coroutines can be unit tested. In here, I use mock. Of course, the suspending functions are a bit more challenging. That's why we need to use co-every and co-verify. But except of that, they work exactly the same. So we can mock suspending functions. We can verify suspending functions. There are even tricks. For instance, if you need to work with timer coroutines, you can make a context that does not work on a normal time. You can just manipulate the time, move it forward and backward. There are many great things you can do with Kotlin Coroutines. And that's basically it. I hope that it was understandable for you. I think it was very challenging since just 35, 40 minutes for all of that, but we have recording for longer things in my workshops take at least half a day to discuss the coroutines. But I think that you got some important lessons and that you have most important concepts. It is time for your questions. Thank you for your attention.